Late 1944. The hedgerows of Normandy had given way to the rolling fields approaching the German border, but for the American tankers inside the M4 Sherman, the fundamental equation of survival remained terrifyingly unbalanced. The enemy they feared most was not the infantryman with his Panzerfaust, nor the hidden anti-tank gun. It was the sudden, heart-stopping appearance of a German heavy tank, the Panther, or worse, the legendary Tiger. Facing these behemoths in a standard Sherman, particularly one armed with the original 75mm gun, felt less like combat and more like a pre-scripted execution. The problem was brutal, unforgiving physics. The frontal armor of a Tiger, I measured a daunting 100 to 120 millimeters of high-quality, rolled homogeneous steel, sloped to increase its effective thickness. The Panther boasted even better ballistic protection, with its sharply angled 80mm glacis plate proving virtually immune to standard Allied tank rounds at typical combat ranges. The American M4 Sherman, designed as a medium tank for infantry support and exploitation, carried significantly thinner armor, and crucially, a gun that simply wasn't designed to punch through that much steel. The standard armor-piercing AP round fired by the Sherman's 75mm gun could reliably penetrate perhaps 70mm of vertical armor at 500 yards. Against the sloped frontal plate of a Panther, this was often reduced to less than 50mm effective penetration, woefully inadequate. Even the upgraded 76mm gun, introduced later to address this deficiency, struggled. Its standard AP rounds might manage 90mm of penetration at 500 yards, still not enough for a guaranteed kill against the frontal aspect of the German heavies. This technical mismatch created a chilling reality for Sherman crews. Doctrine dictated they should avoid frontal engagements with Tigers and Panthers at all costs, seeking flanking shots against the thinner side or rear armor. But combat rarely adhered to doctrine. Ambushes, meeting engagements on narrow roads, or defending against determined German counterattacks often forced the Shermans into hopeless duels they could not win. American tankers watched in horror as their carefully aimed shots bounced harmlessly off the thick German hides, the distinctive clang signaling their own impending doom. The German tanks, armed with powerful long-barreled 75mm or 88mm cannons, could easily destroy a Sherman from distances well beyond the M4's effective range. The psychological toll was immense. Sherman crews felt like they were driving steel coffins, sent out to fight lions with pocket knives. Morale plummeted in units that suffered heavy losses against German heavy armor. The desperate need for a solution, any solution, that could give the Sherman even a chance against the Panzers became the overriding obsession of tankers from the lowest private to the highest command echelons. The Ordnance Department did have a technical answer: the T4 high-velocity armor-piercing HVAP round. Utilizing a dense tungsten carbide core surrounded by a lighter aluminum body, the HVAP projectile flew significantly faster and hit much harder than standard AP rounds. Fired from the 76mm gun, HVAP could penetrate upwards of 150mm of armor at 500 yards, enough to reliably defeat the frontal armor of both the Panther and the Tiger. It was the miracle shell they needed. But HVAP suffered from its own crippling flaw: extreme scarcity. Tungsten was a rare strategic material desperately needed for machine tools and other critical war industries. Production of HVAP rounds was agonizingly slow and perpetually fell short of demand. Official allocation policies often restricted these precious rounds to specialized tank destroyer units, leaving the standard Sherman battalions with only a handful, if any, per tank. A typical Sherman might carry 70 to 100 rounds of main gun ammunition, but perhaps only 2 or 3 of those would be the coveted HVAP. Using one felt like firing solid gold. Saving them for the perfect shot often meant dying before that shot ever materialized. This frustrating reality, possessing a solution that was technically effective but logistically unavailable, pushed the burden back onto the crews in the field. They couldn't change the laws of physics or the global supply chain for tungsten, but deep within the cramped, oily confines of the Sherman turret, one crew member held the key to a potential, if unorthodox, solution: the loader. His job was simple: keep the gun fed. But his intimate knowledge of the ammunition rack, combined with the desperate pressure of combat, would lead to an improvised secret mix of shell types, a tactical workaround born of necessity that could, just maybe, turn the tables on the seemingly invincible German Panzers. Inside the cramped, sweltering turret of an M4 Sherman, the loader was arguably the busiest man in combat. Wedged between the massive breech of the 75mm or 76mm gun and racks of heavy, brass-cased ammunition, his world was a blur of frantic motion and deafening noise. His primary task was brutally simple: grab the correct shell, shove it into the breech, and clear the spent casing, all in the few seconds between shots, while the tank pitched and bucked over rough terrain and enemy rounds hammered against the hull. But beyond the sheer physical exertion, the loader held a unique position. He was the gatekeeper of the tank's lethality, the one who physically selected the type of destruction hurled towards the enemy, and it was this intimate connection with the ammunition stowage that led to the development of the secret mix. Standard doctrine dictated a specific layout for the ammunition racks known as the ready rack, designed for quick access during combat. Typically, this rack held a mix of shells prioritized for expected targets: high explosive, HE, for infantry and soft targets; armor-piercing capped, APC, or armor-piercing; capped ballistic capped, APCBC, for general anti-tank use and perhaps a few rounds of white phosphorus, WP smoke. The precious, rare, high-velocity armor-piercing, HVAP rounds, if available at all, were often tucked away in less accessible stowage bins, reserved by the tank commander for emergency use only, a theoretical situation that often arrived too late. The loaders saw the flaw in this logic firsthand. They witnessed the commander's growing panic as standard AP rounds ricocheted uselessly off a Panther's glacis. They felt the helpless frustration of knowing they had a shell capable of killing the beast, but it was buried under layers of less effective ammunition, requiring precious seconds they didn't have, to retrieve. More critically, they understood the practicalities of the gun breech. Once a round was loaded, changing it quickly under fire was extremely difficult and dangerous. The first shot often determined the outcome of the engagement. From this crucible of desperation, an unofficial crew-level tactic began to emerge, passed along through whispers and shared experience rather than official manuals. Experienced loaders started deviating from the standard ready rack layout. They began keeping one or two of the scarce HVIP rounds right at the front, immediately accessible. This was the loader's gamble, using the rarest ammunition first, against doctrine, betting everything on achieving a knockout blow with the initial shot. The tactic involved a sophisticated understanding of both the enemy tanks and their own limited ammunition supply. The loader, often in coordination with the gunner and commander, would prioritize the HVAP for specific scenarios: a sudden, close-range encounter with a heavy tank presenting its frontal armor. The goal was to use the HVAP's superior penetration to score an immediate kill, or, at the very least, cripple the enemy tank, perhaps damaging the gun mantlet, jamming the turret ring, or shocking the crew. If the first HVAP shot failed to destroy the target but did cause damage, or if the target presented a weaker aspect, side or rear armor, the loader would immediately follow up with the more plentiful standard AP rounds. These rounds, while less effective against thick frontal armor, could often penetrate the sides or exploit damage caused by the initial HVIP hit. Some crews even developed tactics involving a quick switch to high-explosive HE rounds after an initial AP or HVIP strike, aiming to blind the enemy tank by destroying its optics, damage external components, or even concuss the crew through sheer explosive force against the armor plate, a phenomenon known as spalling. This secret mix wasn't a formal doctrine. It was a fluid, adaptive strategy tailored by each crew based on their experience, their commander's nerve, and, crucially, the number of precious HVAP rounds they actually possessed. It required immense skill and coolness under pressure from the loader. He had to instantly identify the required shell type amidst the chaos, retrieve it from the correct position in the rack, and load it flawlessly, all while the tank was maneuvering and firing. A fumbled load or grabbing the wrong shell type could be fatal. This improvised approach directly contradicted the Ordnance Department's conservative guidelines, which emphasized conserving HVAP for ideal, long-range shots or specialized tank destroyer units. But the crews on the front lines knew that ideal situations rarely occurred. They needed to win the fight now, with the tools they had. The loader's decision to keep the silver bullet HVAP round ready for the first shot was an act of tactical rebellion, born from the grim necessity of survival. It was a recognition that against the German heavies, the first shot was often the only shot that mattered, and wasting it with an ineffective AP round was a luxury they could no longer afford. The humble loader, through his intelligent management of the ammunition rack, was finding a way to make the Sherman punch far above its weight. Implementing the secret mix tactic was far more than just rearranging shells in the ready rack. It demanded a fundamental shift in crew coordination and a willingness to operate outside the bounds of official doctrine. The decision to fire the precious HVAP round first was a high-stakes gamble, requiring the commander, gunner, and loader to act in perfect synchronicity, often based on split-second threat assessments. This unofficial first-shot doctrine evolved organically within experienced tank crews, a dangerous but necessary adaptation to the lethal realities of facing German heavy armor. Official U.S. Army armored doctrine, particularly in 1944, still emphasized fire control and ammunition conservation. Tank commanders were trained to identify targets, estimate range, select the appropriate ammunition type based on target analysis, infantry, soft vehicle, medium tank, heavy tank, and then direct the gunner. This deliberate, methodical process was sound in theory, but often too slow for the sudden, brutal encounters common in the European theater. By the time a commander had identified a Panther lurking in ambush, communicated the target, and ordered the gunner to load standard AP while saving the HVAP just in case, the Panther's powerful 75mm KWK-42 L-70 gun might have already fired, potentially destroying the Sherman. The loader's secret mix short-circuited this process. Experienced crews developed an instinctual understanding. If a Tiger or Panther appeared suddenly at close range, typically under 800 yards, presenting its formidable front armor, the unofficial protocol kicked in. The loader, anticipating the command or even acting on his own initiative based on the gunner's frantic turret traverse, would slam the HVAP round into the breach. The first shot had to be the one most likely to penetrate. There might not be a second chance. This approach carried significant risks. Firing the scarce HVAP at a target that could have been defeated by standard AP was considered a cardinal sin by ordnance officers focused on supply conservation. If the HVAP shot missed, or failed to achieve a kill, the crew had expended their best round and were now forced to rely on less effective ammunition against an alerted and dangerous enemy. It was a bet against long odds, but one that crews increasingly felt compelled to make. The alternative, firing standard AP first and watching it bounce harmlessly, felt like suicide. Resistance to this field-expedient tactic often came from inexperienced officers or commanders overly concerned with adhering strictly to regulations. Stories circulated among veteran tankers of green lieutenants demanding loaders stick to the official ready rack layout, only to see their tanks destroyed in the first encounter with a heavy Panzer because the critical HVAP round was inaccessible. Conversely, successful commanders, those who survived and learned, quickly recognized the value of the loader's initiative. They implicitly trusted their loaders to have the silver bullet ready the instant a high-priority threat emerged. The development of this tactic highlighted the disconnect between the logistical realities dictated by high command, HVAP scarcity, and the tactical necessities faced by frontline crews. While ordnance depots carefully rationed the tungsten core rounds, loaders inside the Shermans were making life-or-death decisions about their immediate use. They weren't hoarding the HVAP for a theoretical perfect shot dictated by a manual. They were using it to survive the next 10 seconds. This pragmatic, bottom-up adaptation demonstrates a core strength of the American military system, despite its bureaucratic flaws. While the official channels struggled to supply enough HVAP, the crews themselves devised a method to maximize the effectiveness of the few rounds they did possess. The loader, often the lowest-ranking member of the crew, became a critical tactical decision-maker, his judgment in selecting the first round often determining the fate of the entire tank. The secret mix wasn't just about ammunition placement, it was about empowering the individual soldier to adapt and overcome the limitations imposed by the broader system. It was a small rebellion against doctrine, waged one shell at a time, in the desperate hope of leveling the playing field against Germany's armored beasts. The brutal reality of tank combat in late 1944 often compressed the complex calculations of armor penetration, range, and ammunition selection into a terrifyingly brief window, perhaps 60 seconds or less from initial contact to destruction. In these fleeting moments, the loader's ability to instantly deliver the correct shell, particularly the scarce HVAP round when facing a heavy German tank frontally, became the single most critical factor in the Sherman's survival. The secret mix wasn't just a clever stowage plan, it was a high-speed system designed to win duels that, according to the specifications, the Sherman should have lost every time. Imagine the scene. An American Sherman platoon advancing cautiously through the Hürtgen forest or across the rolling fields near the Siegfried line. Suddenly, a Panther tank, perfectly camouflaged, opens fire from 800 yards. The first German shell screams past, or worse, impacts with a deafening clang. The American tank commander instantly identifies the threat. Under standard doctrine, the exchange might proceed slowly. Gunner, traverse left. Target, Panther. Range 800. Then the agonizing decision, load AP. The gunner fires. The round bounces off the Panther's glacis. The Panther fires again, this time hitting center mass. Another Sherman lost. Now replay the scene with a crew employing the secret mix. The moment the commander screams Panther, front. The loader, already anticipating the threat, has the HVAP round in his hands. He slams it into the breach even as the gunner is laying the crosshairs on the target. The commander might only need to shout, fire! The first American shot is the HVAP. If aimed well, perhaps at the turret face or the vulnerable gun mantlet, it has a real chance of penetrating, killing crew members, jamming the turret, or causing catastrophic damage. Even if it doesn't achieve a kill, the high-velocity impact often shocks the German crew, disrupting their aim for the critical follow-up shot. In those vital seconds bought by the HVAP impact, the loader is already ejecting the spent casing and ramming home a standard APCBC round. The gunner adjusts his aim, perhaps targeting the tracks or a point weakened by the first hit. The Sherman fires again. This rapid, coordinated sequence, HVAP first, followed immediately by AP, was the core of the improvised doctrine. It relied on the loader's speed, the gunner's accuracy under immense pressure, and the commander's willingness to trust his crew's aggressive, non-standard tactics. Of course, the gamble didn't always pay off. If the initial HVAP shot missed entirely, a real possibility against a moving target or under the stress of incoming fire, the Sherman crew found themselves in a desperate situation. They had expended their single best round, and now faced an alerted, undamaged heavy tank with only standard ammunition. In these instances, survival often depended on deploying smoke, reversing rapidly into cover, or relying on other tanks in the platoon to draw fire or achieve a flanking shot. The secret mix was not a guaranteed solution, it was a calculated risk, an attempt to increase the probability of survival in an otherwise near-certain death scenario. The psychological impact on the German crews facing this tactic, while harder to document directly, can be inferred. They knew their frontal armor was largely immune to standard Sherman rounds. Yet, occasionally, inexplicably, a first-shot hit from a seemingly ordinary Sherman would result in penetration and devastating internal damage. This unpredictability eroded the confidence that came with technological superiority. Was this Sherman one of the few carrying the dreaded HVAP? Was the first shot going to be the lucky one? This doubt, however small, could disrupt their aiming process, force them into more cautious maneuvers, and potentially level the playing field just enough for the numerically superior American tanks to close in. The loader's hidden ace, the HVAP round waiting in the ready rack, cast a shadow of uncertainty over every encounter. While the loader's secret mix provided a crucial tactical edge in individual tank duels, it existed within a larger, often brutal context of logistical scarcity. The high-velocity armor-piercing HVAP round was not just rare, its availability fluctuated wildly, turning the fight against German heavy tanks into a desperate tungsten lottery. The effectiveness of this field-expedient doctrine was always hostage to the unpredictable trickle of specialized ammunition arriving from the rear. The core problem remained the global shortage of tungsten, the incredibly dense metal required for the HVAP core. Allied strategic planners prioritized tungsten allocation for critical industrial uses, machine tool tips, electrical components, and armor-piercing shells for larger caliber anti-tank guns and naval ordnance. Tank ammunition, particularly for the ubiquitous Sherman, often received a lower priority. This meant that even as the Ordnance Department acknowledged the HVAP's effectiveness, the production line simply could not generate enough rounds to meet the voracious demand of thousands of Shermans facing increasingly heavy German armor. This scarcity created immense pressure on the supply chain and fostered a climate of hoarding and unofficial distribution. Ammunition supply points often received only a handful of HVAP crates per shipment. These were supposed to be allocated according to official directives, typically favoring specialized units like tank destroyer battalions, equipped with the more powerful 3-inch or 90mm guns. However, informal networks and desperate pleas from frontline Sherman commanders often led to HVAP rounds being lost, misdirected, or unofficially traded to units facing immediate threats from Tigers or Panthers. A savvy supply sergeant might find an extra crate for a battalion commander who knew how to ask the right way, while by-the-book officers received only their meager official allotment. For the individual tank loader, this meant the secret mix was often a strategy employed with only 1 or 2 HVAP rounds available for the entire tank's combat load. The decision of when to use that single silver bullet became agonizing. Was this Panther the real threat, or was there a Tiger lurking just beyond the next ridge? Firing the HVAP too early could leave the tank defenseless against a subsequent, more dangerous encounter. Holding it too long could mean destruction before it was ever used. The loader wasn't just managing ammunition, he was managing probabilities of survival based on incomplete information and extreme stress. This constant anxiety about HVAP availability also drove further improvisation. Crews learned specific weak points on German tanks that might be vulnerable even to standard AP rounds if hit precisely: the turret ring, the lower glacis plate seam, the commander's cupola. Gunners practiced hitting these tiny targets, hoping to achieve a mobility kill or jam the turret, even without the penetrating power of HVAP. Some crews experimented with firing white phosphorus, WP, smoke rounds directly at the vision ports of heavy tanks, attempting to blind the crew and force them to button up or withdraw, buying precious time for flanking maneuvers or escape. The secret mix tactic, therefore, was not a universal solution that magically leveled the playing field. It was a symptom of a deeper systemic failure, the inability of the Allied industrial machine to produce and distribute the truly effective anti-tank ammunition in sufficient quantities when it was most needed. The loader's ingenuity was a testament to the adaptability of the American soldier, but it was also a reflection of the desperation created by facing superior enemy armor with inadequate standard ordnance. While the tactic undoubtedly saved lives and turned the tide in countless small engagements, it did so by relying on the careful husbanding and precise application of an incredibly scarce resource. The war against the German heavies was won not just by courage, but by the loaders who knew how to play the tungsten lottery and make their single winning ticket count. While the secret mix tactic was never officially codified in training manuals, its impact rippled through the battlefields of Western Europe, becoming an unseen equalizer in the deadly calculus of armored warfare. The sporadic, unpredictable success of Sherman's against supposedly invulnerable German heavy tanks created confusion and doubt within the Wehrmacht's armored corps, contributing to a gradual erosion of their perceived technological dominance. German intelligence, meticulous in analyzing captured equipment and interrogating prisoners, struggled to reconcile the technical specifications of the Sherman's 75mm and 76mm guns with the increasing number of reports detailing frontal penetrations on Panthers and even Tigers. They knew about the existence of American tungsten core ammunition, HVAP, but based on their own severe shortages of tungsten, they drastically underestimated the scale at which it might be available even sporadically to frontline American units. They assumed such potent ammunition would be reserved exclusively for specialized tank destroyers, not integrated into the standard loadout of ubiquitous Sherman tanks. This misunderstanding led to flawed tactical assessments. German commanders continued to operate their heavy tanks with a degree of confidence in their frontal armor, sometimes exposing themselves to Shermans at ranges they believed were safe, only to be unexpectedly knocked out by a single high-velocity projectile. These inexplicable losses fueled rumors and anxieties among Panzer crews. Was there a new, secret American gun? Were the standard Sherman shells more powerful than believed? The uncertainty itself became a weapon, forcing German tankers to be more cautious, potentially surrendering tactical initiative. The American crews, meanwhile, refined the secret mix through brutal trial and error. Loaders became experts at estimating the probability of needing the HVAP based on terrain, intelligence reports, and the commander's immediate assessment. Gunners learned the precise aiming points, the lower edge of the gun mantlet, the driver's vision port, the turret ring, where even a standard AP round might jam the turret or cause spalling if the HVAP wasn't available or missed. Commanders learned to coordinate platoon tactics to maximize the chances of a flanking shot while conserving their precious HVAP for the unavoidable frontal encounters. This decentralized, adaptive learning process stood in stark contrast to the rigid, top-down German system. While American crews were developing battlefield hacks to overcome their equipment's limitations, the German response often involved waiting for official modifications or new, more complex tank designs, solutions that arrived too slowly and in insufficient numbers. The effectiveness of the secret mix also highlighted the critical role of crew training and experience. A veteran Sherman crew working together seamlessly could execute the HVAP-first tactic with astonishing speed and precision. A green crew, fumbling with unfamiliar shell types under fire, might fail catastrophically. This underscored the fact that technology alone did not win battles. It was the human element, the skill, courage, and ingenuity of the soldiers operating the machines, that often made the difference. The loader, typically the least celebrated member of the crew, became, in these critical moments, the linchpin holding the line against Germany's best armor. The Ordnance Department eventually caught up, increasing HVAP production and improving distribution by late 1944 and early 1945. But for the crucial months following D-Day, during the brutal slog through France and the Low Countries, it was the unofficial secret mix doctrine, practiced by thousands of anonymous loaders in countless desperate engagements, that provided the essential counterpunch against the Panther and the Tiger. It wasn't the perfect solution the engineers desired, but it was the available solution that kept the Shermans fighting and dying, but ultimately advancing. The simple act of rearranging shells in a ready rack became a small but vital part of the complex machinery grinding towards Allied victory. The story of the loader's secret mix resolves not as a tale of technological triumph, but as a testament to the power of human adaptation in the face of systemic limitations. The M4 Sherman, armed with its standard 75mm or 76mm gun, was never designed to go head-to-head with the German heavy tanks. Official doctrine and engineering specifications placed it at a clear disadvantage. Yet, on the battlefields of Europe, Shermans did kill Panthers and Tigers, often against improbable odds. This success was not solely due to numbers or air support. It was significantly enabled by the ingenuity and courage of the crews, particularly the loaders who devised ways to maximize the lethality of their limited arsenal. The secret mix tactic, prioritizing the scarce HVAP round for the critical first shot, was a direct rejection of conservative top-down ordnance policy. It was a solution born from the mud, blood, and desperation of frontline combat, developed by the men who intimately understood the physics of survival. It acknowledged a brutal truth that logistics officers preferred to ignore. In a close-range duel with a Panther, the theoretical value of conserving a rare shell was meaningless compared to the immediate value of surviving the next 60 seconds. The German engineers had created masterpieces of armored warfare, optimizing for firepower and protection above all else. But their pursuit of perfection resulted in complex, resource-intensive machines that were difficult to produce in sufficient numbers and notoriously unreliable in the field. The American approach, embodied by the Sherman, prioritized mass production, mechanical reliability, and adaptability. The secret mix was the ultimate expression of this adaptability, a software fix implemented by the crew to compensate for a hardware limitation. The legacy of this improvised tactic is a crucial lesson in military history. Technology sets the parameters, but human ingenuity often determines the outcome. The Sherman's gun was statistically inferior, but the loader, who knew precisely when to use his single HVAP round, combined with a gunner who could hit a Panther's weak spot, could achieve results that defied the technical specifications. This human element, the ability to learn, adapt, and take calculated risks, proved to be a force multiplier that German planning, focused on machine performance, consistently underestimated. The final verdict rests not on the penetration charts or the armor thicknesses, but on the operational reality. The German heavy tanks, while individually formidable, were often unavailable due to mechanical failures or outnumbered due to slow production. The American Shermans, kept running by reliable engines and supported by crews who found ways to make them deadly even against superior foes, maintained a constant grinding pressure on the battlefield. The loader's decision to keep that HVAP round ready wasn't just about ammunition, it was a symbol of the American willingness to bend the rules, trust the man on the ground, and find pragmatic solutions when the official system fell short. Ultimately, the story of the secret mix reveals that the most effective weapon is not always the one with the biggest gun or the thickest armor. It is often the one operated by a crew that understands its limitations and creatively exploits every possible advantage. The humble loader, often overlooked in tales of tank aces, played a vital, unsung role in turning the tide, proving that even against technological Goliaths, a well-placed shot, enabled by a simple, intelligent tactic, could make all the difference.